Thanks for tuning in here. We have our Unit 1 test review. Unit 1 test is coming up real soon, so we'd like you to be as prepared as possible. So we put together this PowerPoint review for you. It's going to cover the major ideas of Unit 1, and if you can follow along and take some notes, practice with us here, it'll get you well prepared. So let's start here. We'll ask two questions right off the bat. These are kind of some vocabulary words we've been using. What is another way to say multiplicative inverse? We talked about this. This is kind of the annoying way of saying something pretty simple. The one right below it says, what is another way to say additive inverse? And if you recall, what we talked about, if you look at your notes there even, is what we said, multiplicative inverse has a much easier word, and the easier word that we can use is, you might have guessed it by now, reciprocal. Okay? So now reciprocal is the word they're going to use 5th grade, 6th grade, 7th grade. You'll hear it again, but from algebra and on up, they're going to be using this term multiplicative inverse. And what about this additive inverse? There's an even easier word for that, which is to say what? The opposite. The opposite. Say the additive inverse. And there's a reason for this, as we'll get to in just a minute here when we look at these. But let's take a look here, and we'll answer these formally. Another way to say multiplicative inverse, well, we would just do this. We would say a reciprocal, that is two rational numbers that multiply to 1. Two rational numbers. So what does that really mean, two rational numbers? All we're saying here is, if you have something like this as an example, let's say 2 over 3, that's a rational number, times 3 over 2. Well, if we multiply straight across, 2 times 3 is 6, 3 times 2 is 6, 6 divided by 6 is 1. Therefore, we've proven that these two are reciprocals of each other. Why is that? Because their product is 1. The definition of a multiplicative inverse says that the answer is 1, and we just proved that. And additive inverse, let me get rid of my work here. The additive inverse, the other way to say that, and probably the easier way to say, is the opposite. These are two numbers that add to 0. Okay, additive inverse adds to 0, multiplicative inverse multiplies to 1. So what's the multiplicative inverse of negative 2? So I want you to think about that for a second. Maybe you pause the video and think what you think. What do you think about multiplicative inverse of negative 2? We know we have to multiply something by that to get positive 1. That's the definition, right? So if we took negative 2 and put it over 1, what is negative 2 times what will get you to 1? And then right below that, we've got this additive inverse, and the additive inverse here of negative 2 means negative 2 plus something equals what number? Well, by definition, it's 0. So why don't you consider those for a second, and then we'll give our answers here. So take a look at this. Multiplicative inverse of negative 2, hopefully you put down negative 1/2. What's a negative times a negative? Positive. What's the reciprocal or the multiplicative inverse of negative 2? Negative 1 over 2. And how about the additive inverse of negative 2? Well, that should just be positive 2. Negative 2 plus 2 would be 0. And of course, these are just simple examples. We can place anything you want in there, as we'll see as we move a little bit further along. All right, why don't you do this? I have four problems there on the left-hand side. Why don't you practice these, and then answers will follow here. So maybe you press pause, write those down, write down some answers, and then we'll be right back with you. Okay? All right then, let's say that you've done that and you've come back, and we've got this right here. We've got 4/5 times 5/4. You could reduce, that's true. We could simplify by reducing these down and get some 1s. Maybe just to prove the point about this, these reciprocals or multiplicative inverses being 1. Multiply straight across, what's 20 over 20? Well, 20 divided by 20 is indeed just 1, so there's your answer there. How about this? 3 over 7 times what is the product of 1? Well, if you look at the pattern here and consider the definition, if we have a product of 1, we must be multiplying by the multiplicative inverse of 3 over 7. So what is the reciprocal of 3 over 7? 7 over 3. And I think the third and fourth ones are pretty easy. Negative 4 plus 4, these are additive inverses. We get 0. And 8 plus what would be 0. Negative 8 is the correct answer there. All right, why don't you try these? Okay, we have 4 more here. So take a look at those. You don't have to write all those words down in your notebook, of course. Just answer them in order, and I'll be right back with you here. All right then, there at the top, you've got state the additive inverse of 3. So that means 3 plus something gets you what answer? Well, in this case, 0. So what is the additive inverse of 3? Negative 3. State the additive inverse of negative n. So negative n. Negative 3, negative n, or 3 and n. It doesn't really matter what we're doing there. We're just looking for the additive inverse. So what is the opposite of negative n? Positive n. Whatever n happens to be, n plus negative n or vice versa is going to add up to 0. How about the third one? State the multiplicative inverse of 5. Multiplicative inverse of 5. Well, you know that we can write 5 as 5 over 1. So what's the reciprocal of 5 over 1? 1 over 5. Okay. And the last one there, state the multiplicative inverse of y. Well, now we don't know what y is, and moreover we don't care. We do know that we can write y as y over 1. So again, what's the multiplicative inverse or the reciprocal? 1 over y. Okay? And of course, anytime you have any questions here, make sure you bring those questions up in class. It's the old saying, if you have the question, there's probably 3 or 4 others that have it as well. So you're doing everybody a favor. All right, let's look at the next ones here. I got a couple of problems here. Let's see. A little bit of variety. It says, how do you write this as a power? Whenever you see the word power, it means just write it using exponents. The second one says, what is the reciprocal of 3 over 4? And then the bottom two down here, we have some work that we're familiar with. The principal square root of 25 plus the cube root of 125. And then a subtraction problem, the cube root of 8 minus the square root of 64. So take a look at those, and why don't you press pause, write down some answers, and then we'll come back and check your work, and I'll be waiting here for you. All right then, so how do we write this as a power? So if you're looking at this one, the first one here, you've got this, let me go grab my pen here, and we've got n. We don't know what n is, doesn't matter, it's just a number that's kind of hidden behind a letter there. How many n's do you see there? Well, we have 1, 2, 3, 4 of them. So whenever we say the word power, it really means just to use exponents here. So what we're looking at then is, let's see, how about n to the 4th? Good. So you have n is the base, it appears 4 times, and we're multiplying, so n to the 4th. What's the reciprocal of 3 over 4? Another way to say reciprocal is multiplicative inverse. So you may be asked, what is the multiplicative inverse of 3 over 4? What do? We just take the numerator denominator basically and flip them. And we know that 4/3 times 3/4, what would be the product? Well, that would be 12 over 12, which indeed is 1. How about the bottom two here? Now we have this square root 25. The principal square root of 25, I think we know that's 5. What about the cube root of 125? Well, I'm thinking about a number now that is times itself. 5 times 5 is 25 times 5 again. So how about 5 plus 5 is 10? That makes sense? Okay. And subtracting, cube root of 8 minus the square root of 64. So cube root of 8, give me a number multiplied itself 3 times to get you 8. How about 2? And then negative or subtracting square root of 64, I think we're looking at negative 8. So how about negative 6 there for an answer? All right, so go ahead and check and see how you did on those 4. All right, let's move forward here. Got another 4 for you in a straight line. So let's check those out. We don't really have to review all those word for word. We'll just put some answers up there, and I'll wait right here while you pause and write those answers down. Okay then, how about this? The principal square root of 121. Did you get 11? That'd be good. Remember that 11 times 11, of course, is 121. How about this? The square root or the principal square root of 49 over 81. The reason I say principles, you'll find out later that we're going to be looking at multiple answers here for these square roots, but we'll see that in Chapter 11, way ahead in May or maybe early June as we finish up our year together. So 49 over 81, what was our thing we learned about this? Remember that when you're looking at this, you try to reduce first inside the radical. If you can't, then you can take the square root of the numerator over the square root of the denominator. And square root of 49, well, the principal square root of 49 is positive 7, and the principal square root of 81 is positive 9. So 7 over 9, that can't be simplified, so we're all done there with our work, 7 over 9. How about this? The negative cube root of 27. The negative, or another way to say that, is the opposite of the cube root of 27. Cube root of 27, we've practiced that a lot. We've practiced cube roots a lot together. So hopefully you know that is 3. What's the opposite of positive 3? So maybe you got the answer of negative 3. That would be good. And how about this last one here, 25 over 100? Now, as we said earlier, we would like to be able to reduce first before we take the square root. Can we reduce 25 over 100? Maybe we could. Maybe we could reduce this down. We know that 25 goes into 25 one time, and 25 goes into 100 4 times. And now we have a nice, pretty simple answer. Square root of 1 over square root of 4. And I think we're going to get our answer here pretty quickly. 5 over 10. Oh, that's the different approach. Look at that. What they did here was they took the square root of the top and the square root of the bottom, which gave square root of 25 is 5, square root of 100 is 10. And we still get 1/2 though. So either way you go, reducing first or not, we still end up with the same result. All right, here's 4 more, or actually 2 more. Evaluate if A equals 1 and B equals 2. And evaluate in the second one there if A equals 1, B equals 2, and C equals 3. So basically, remember what evaluate means. Plug in the value and simplify. All right, I'll wait right here. Go ahead and press pause, finish those real quick, and I'll see you in a minute or so. All right then, so what I'm going to do is wherever we see the letter B, I'm going to plug in, I'm looking at the top one now, I'm going to plug in a 2. And wherever we see the letter A, I'm going to plug in a 1. And it looks like I've got 2 times 2 minus 1. Well, that's pretty straightforward. 2 times 2 is 4, minus 1. We should end up with 3 here. And the second one, a little more complicated. We've got b squared minus 4ac. So wherever we see the letter B, I plug in a 2. And wherever we see an A, I plug in a 1. And a C, we plug in a 3. And we end up with 2 squared minus 4 times 1 times 3. And just remember an old guy trick here that we've talked about a lot. Do this first, we get 4, and now here multiply backwards, okay? And you'll see why this is going to come in handy later. When you have a string of numbers like this, just multiply this way. Remember that multiplication is commutative, so you can multiply in any order. This will just save you some heartache later. 3 times 1, well that's 3, times negative 4. 3 times negative 4 is negative 12, and now combine those. 4 and negative 12 gets you to negative 8. All right, I think I have 2 more here, and these are going to really stretch us out and put us into this really complicated evaluating thing. It says find the 2 solutions if you evaluate A equals 1, B equals 4, and C equals 3. Remember, we talked about these types of problems can sometimes have more than one solution. I know that's new for us, but in algebra we can often have no solution, 1 solution, 2 solutions, and as you get further along, if you go far enough, you can have more than that as well. But nonetheless, let's go ahead and plug these in and see what you get. Don't forget about this opposite sign in front of B, and let's see how this works. So if you want to give that a try, I'll wait right here. I'm not going anywhere. You can press pause, try that out, and we'll see how you did. All right then. So that might have taken a little bit longer than the previous problems, but here's what we did here. The first thing is we went ahead and plugged in the values. And now we're going to clean up the expression here. We're going to do the easy stuff first. That's what we try to encourage you to do here in math, is do the easy stuff at the beginning. So what do? We took 4 and we plugged it right here in. Wherever you see the letter B, we put in a 4. And then we took 1 and we plugged it in for A right here. And then we took 3 and plugged it in for C. We put an A right here as well. Okay. And now let's go ahead and clean this up. 4 squared, well, first we have the opposite of 4, and inside this radical sign you've got 4 squared. Well, what's 4 times 4? That's 16. And then if we multiply backwards again, 3 times 1 times negative 4. So we end up with something like this. Negative 4 plus or minus the square root of 16 minus 12, all of that over 2. All of that over 2, because 2 times 1 is 2. That's pretty straightforward. So let's take care of what's inside the radical. What is 16 subtract 12? Well, that's pretty simple. That's 4. So let's leave the first part alone. We're going to end up with negative 4 plus or minus the square root of 4 over 2. This plus or minus means that we have an addition and subtraction to consider here. So if we look at negative 4 plus the square root of 4, what's the square root of 4? Square root of 4 is 2 in both cases. So we end up with negative 4. Let me go ahead and grab my pen here real quick. It's on the other side. I'll grab this just so we can look at this together. We know that this square root of 4 is going to be 2, but we're going to have to consider adding it and subtracting it. So negative 4 plus 2, and our denominator was 2, and negative 4 minus 2 over 2. And we just have to be careful with our 7th grade math here when we add these integers. So negative 4 plus 2 is going to be negative 2 over 2. Well, what is, in this case, negative 2 divided by 2? Hopefully you see that's negative 1. What about this? Negative 4 minus 2. We could also say negative 4 plus negative 2 if you'd like. And this is going to be negative 6 over 2. And let's see how this worked out for us. So there's our final result, negative 1 comma negative 3. Now in this case, I just listed them in the order in which they appeared. Generally speaking, you want to put them from least to greatest, okay? But I intentionally wrote them like that so you would see the connection between the first one being negative 1 and the second one being negative 3. So here you have an example where there's 2 answers in one problem. And just a little preview, a little foreshadowing of what's to come, that has everything to do with the beginning of the problem when we ask you for this b squared here. See this exponent of 2 way up here at the top? I kind of messed that up a little bit, but up here at the top, this 2, that really tells us that we could possibly have more than one answer. Alright, and let's try one more here. And this one's going to be a little messier. I'll give you a little warning on that, but that's okay. Let's try it. So find the 2 solutions if you evaluate 3, a equals 3, b equals negative 3, and c equals negative 1. Plug those in and see what you get. And I'll be right here when you get back. Okay, did you plug those in? Now when you plug these in, for the value of b we have negative 3 here. So what does this symbol out in front mean? This means the opposite of whatever b is. So if b is already negative, what's the opposite of any negative number? Well, it's the positive value of that number. So when we plug it in, we just need to be careful over here when we're looking that we get all these put down correctly. And that's one thing you want to do is just double check. You know, we don't have to be in a hurry here. The number of problems will diminish as the further you go up in algebra and the higher math. You'll get fewer problems for the most part, but they'll be more complicated. So kind of slow down, double check your work, and make sure that you're still on the right track. So b is negative 3. The opposite of negative 3, well, we know that's going to be positive 3. Inside here, you've got b squared, so it's negative 3 squared. Remember that a negative times a negative is going to be positive, so this will be a positive value. And now if we remember our trick to multiply backwards, we should end up, and I think I see a little typographical error here. What is c here? C is negative 1. And what do I have here? I have a positive, so I need to be careful there. So my apologies there. That should be a negative 1 right here. Okay? So when we plug these in, you see what I did. By double checking myself right here in front of you, I found an error. Okay? So when we go through, I've got 3. I got that right. It's negative 4ac, and c is negative 1. Yeah, so there's the mistake. Okay? So that's fine. So that's a good example for you to double check. I've been doing this for a little bit, and still we make those mistakes. Alright, so let's go ahead and continue. Let's see if we cleaned it up as we went forward here. Yeah, we did. Okay, so what we ended up here was the opposite of negative 3 is positive 3, plus or minus the square root. What did we say negative 3 squared was? We said that was 9. And then, even though I wrote positive 1 here, I guess I had in mind negative, because negative 1 times 3 times negative 4 is going to be positive 12. Alright, positive 12. Now, if we look inside the radical sign, we have 9 plus 12. Well, we know 9 plus 12 is going to be 21. So when we write this, we end up with 3 plus or minus the square root of 21 over 6. Now the reason we immediately say that's the end of the problem is because the square root of 21, there is no reasonable, rational answer for that. This is an irrational number, so we're not going to worry about it. Okay, we're not going to get a calculator and punch it in and get some long decimal. That would be for a science class or an experiment or something like that. For us in pure math, we're just going to simply plug in square root of 21 and say that's it. So your final result, notice that I said we're going to find the 2 solutions. The 2 solutions here. But you may say, well, there's only one here. But if you look carefully, this is actually saying 3 plus the square root of 21 over 6. And the next answer is 3 minus the square root of 21 over 6. And the high school, college, fast way to write that is just like this. 3 plus or minus the square root of 21 over 6. Okay? Alright then, I know it's kind of a tough problem there. And but we got through it despite my little error there in the typing and the problem in. All right, that pretty much covers the breadth of what we're going to have for Unit 1. Make sure you practice as much as possible. Remember, the unit tests weigh pretty heavily with you, and because it's a mastery course, you're going to need to hit a 70% or higher in order to move forward to Unit 2. And if not, if you stumble here, we'll be here to help you and redirect and reinforce, and we'll put a team together to help you get past this Unit 1 and get right back up to speed. All right then? Okay, hope you had a good time, and we'll see you soon.